Theorem 13. If two triangles ABC and DEF are similar, then their sides are proportional in the order that AB divided by DE is equal to BC divided by EF is equal to AC divided by DF. So what are we given? So we're given the triangles ABC and DEF such that angle 1 equals angle 4, 2 equals angle 5, and angle 3 equals angle 6. Now we're asked to prove that the length AB divided by the length DE is equal to the length BC divided by the length EF is equal to the length AC divided by the length DF. So the construction. So mark X on AB such that the length AX is equal to the length DE. So I'm going to mark X just right here. And mark Y on AC such that the length AY is equal to the length DF, and then join X to Y. Now, so for the proof, so the triangles AXY, so the triangle AXY and the triangle DEF are congruent triangles. Why are they congruent triangles? Because the length AX is equal to the length DE. We're after proving that, or showing that by the construction. Angle 1 equals angle 4. We were given that at the start. And AY is equal to DF by the construction. So because of side, angle, side. So they're congruent triangles because of side, angle, side. Now, as a result, we can now look at the angles within these two triangles. So the angle AXY is equal to the angle DEF. So they're both equal to angle 5, and the reason for that is because they're corresponding angles into congruent triangles. Now we can also similarly say that AYX, the angle AYX is equal to the angle DFE, because they're corresponding angles into congruent triangles. So I just put in number 6 there. Now by looking at the triangle again, we can say that the angle AXY is equal to the angle ABC. And the reason we can say this is because we were given that the angle ABC is angle 2 is equal to the angle DEF, which is angle 5. And we have already shown by using the congruent triangles that the angle DEF, which is number 5, is equal to the angle AXY, which is also number 5. So therefore we can say that the angle AXY and ABC are equal. And if you look at those two angles are equal, and they're also corresponding angles. So therefore these two lines here, XY, so therefore XY must be parallel to BC for those to be corresponding angles. So corresponding angles, that's the reason for that. So now we draw back on the theorem. A line parallel to one side divides the other side in the same ratio. So therefore, by looking at that, we can say that the length AB divided by the length AX is equal to the length AC divided by the length AY. So AB divided by AX is equal to AC divided by AY. And we can also then conclude from that that AB divided by, we know that AX is equal to DE, so we can, instead of writing AX, we can write DE is equal to AC, and similarly AY is equal to DF. So we can replace it with that. So similarly, you can prove that AB all over DE is equal to the length BC all over EF. So our full result is, as we started out, the length AB all over DE is equal to the ratio of the length AC all over DF is equal to the ratio of the length BC all over EF.